Entropy is like a messiness level in a room. Imagine you are playing with your toys, and you leave them all over the floor. It's hard to find what you want to play with, and it's not very fun. That's like high entropy. But if you put your toys away in their proper places, it's easy to find what you want, and it's more fun to play. And that's like low entropy. So entropy is a way to measure how messy or organized something is. Entropy is a big idea that scientists have been thinking about for a long time. A long time ago, people started to notice that things in nature tend to go from being organized and orderly to being messy and disorganized. They wanted to come up with a way to measure how much disorder there was in a thing, and that's where the idea of entropy came from. A man named Rudolf Clausius was one of the first people to really study entropy and figure out how to measure it. He came up with the idea that entropy is like the amount of energy in a system that can't be used to do useful work. It's kind of like the energy in a toy that's run out of batteries and can't move anymore. After that, other scientists like Ludwig Boltzmann, Max Planck, and Albert Einstein started to study entropy too, and they found out that entropy can help us understand why things in nature tend to go from being organized and orderly to being messy and disorganized. They also found out that entropy is related to the second law of thermodynamics, which says that the disorder in the universe is always increasing. So entropy is an idea that scientists have been thinking about for a long time, and they're still thinking about it today. It helps us understand how things in nature work, and it's a really important idea for scientists to know about. The second law of thermodynamics states that in any energy transfer or transformation, the total entropy of a closed system will always increase over time. In simple terms, this means that in any process energy will be spread out and become less useful over time. Entropy is a measure of the disorder or randomness in a system, and as entropy increases, the system becomes more disordered and less useful. In a closed system, such as the universe, the total entropy will always increase, meaning that the universe will always become more disordered and less useful for doing work over time. For example, imagine you have a cup of hot coffee and a cup of cold coffee. If you leave them alone, the hot coffee will eventually become lukewarm, and the energy that was in the form of heat will have spread out and become less useful. This is an example of entropy increasing in accordance with the second law of thermodynamics. The second law of thermodynamics states that entropy always increases in closed systems, and entropy is a measure of disorder and randomness in a system, meaning that a closed system will become increasingly disordered and less useful over time. In information theory, entropy is used as a measure of the randomness or uncertainty of a random variable. A random variable is a variable whose value is uncertain and can take on different outcomes based on probability. For example, the outcome of a coin toss is a random variable because it can be either heads or tails, and the probability of either outcome is 50%. Entropy in this context is a measure of the uncertainty of a random variable. The more uncertain a random variable is, the higher its entropy will be. For example, in the coin toss example, the entropy would be highest because there are two equally likely outcomes. On the other hand, if the random variable is certain, the entropy would be 0. For example, if we know that a coin is not fair and will always land on heads, the entropy would be 0 because the outcome is certain. Entropy is also used in digital communication and cryptography to measure the amount of uncertainty in a message. It is used to determine the amount of information present in a message, and to measure the amount of uncertainty in the message, which is useful to encrypt it. In information theory, entropy is used as a measure of the randomness or uncertainty of a random variable. The more uncertain a random variable is, the higher its entropy will be. It is also used in digital communication and cryptography to measure the amount of information present in a message and the amount of uncertainty in it. Entropy is related to the concept of disorder in the natural world in several ways. One example is the tendency of systems to move towards a state of equilibrium, where the distribution of energy is as evenly spread out as possible. This can be observed in everyday phenomena such as heat transfer, where heat flows from a hot object to a cold one, until both objects reach the same temperature. Another example is the tendency of living systems to degrade over time. All living organisms require a constant supply of energy to maintain their structures and carry out their functions. As they use this energy, they create waste products and eventually degrade and die. This process is also an example of entropy increase, as the organism becomes more disordered and less able to carry out its functions. Entropy can also be observed in the natural process of weathering and erosion, where rocks and other materials are broken down and worn away over time, becoming more disordered and less structured. This is also an example of entropy increase as the materials become less structured and more disordered. Entropy is related to the concept of disorder in the natural world in several ways, such as the tendency of systems to move towards a state of equilibrium, the tendency of living systems to degrade over time, and the natural process of weathering and erosion. All these examples show the increase of disorder and randomness in the system. Understanding entropy is important for predicting and manipulating the behavior of systems because it provides a way to quantify the disorder or randomness of a system. By knowing the entropy of a system, we can predict how it will behave and what its limitations are. For example, in thermodynamics, understanding entropy allows us to predict the maximum efficiency of heat engines and the direction of heat flow. In information theory, understanding entropy allows us to predict the amount of information that can be transmitted over a communications channel and to design efficient coding and compression algorithms. In the natural world, understanding entropy allows us to predict the behavior of weather patterns and ecosystems, and to design sustainable systems that minimize entropy increase. Furthermore, understanding entropy also allows us to manipulate the behavior of systems by controlling the flow of energy and information, and by designing systems that are less disordered and more structured. For example, in thermodynamics, it allows us to design more efficient heat engines and refrigeration systems. In information theory, it allows us to design more efficient communication systems and data compression algorithms. In summary, understanding entropy is important for predicting and manipulating the behavior of systems. It provides a way to quantify the disorder or randomness of a system, allowing us to predict its behavior, limitations, and to design systems that are less disordered and more structured. Imagine if the toy box that you have in your room is like the universe and all the toys inside it are like all the energy and matter that exist in the universe. And let's imagine that one day, you decided to take all the toys out of the toy box and mix them up, so they're all jumbled together in a big pile. Can you still find the toy that you want to play with? Can you still have fun with them? Now, think about the universe. If all the energy and matter were jumbled up and disordered, would it still be possible for us to have life, to have stars and planets, to have everything that we know and love? This is what entropy is. It's the measure of disorder and randomness in a system. And understanding it can help us understand the fate of the universe and the way that the natural world works.